Okay, hi, my fifth grade friends. We are back. Really excited that we're going to do um, Elephant Toothpaste. I'm really hoping that you guys can do it at home. I did realize that it is possible, and I'll show you that later. Um, so let's go through, and at least you're going to get to see what happens. Okay, so we're talking about chemical reactions today. So in a chemical reaction, we know, we talked about it before, that the reactants are the substances that you start with, right? That's all these, the substances you start with. The products are the things that you're going to end with. During a chemical reaction, what happens is the molecules just rearrange, they move around, they recombine, and they form different substances. But what you need to know is that the number of atoms that you start with are going to still be equal to the number of atoms that you end with. Here you look, there's one molecule of water. So it's got 2 hydrogen atoms and 1 oxygen atom. This is how that's written. So 2 hydrogen, that little 2 tells us that there's 2 hydrogen atoms and 1 oxygen atom. In a molecule of hydrogen peroxide, you've got 2 hydrogen atoms and 2 oxygen atoms. Okay, that's what the little 2's are. That one extra oxygen atom makes a huge difference. Water we drink, we need it to survive. Hydrogen peroxide is used as like a disinfectant. Okay, so that's the difference between hydrogen peroxide and water. That's important to know because it's part of our chemical reaction today. So when you have hydrogen peroxide, if you had it in a cup, slowly over time, a chemical reaction would happen anyway. If you just left it sitting out, over time, slowly, hydrogen peroxide goes from being hydrogen peroxide to being water and oxygen gas. What we're doing today is we don't want to wait that long. That's going to be boring. We want to see something fun happen. But if we add something to it to speed up that reaction, it's going to be a lot more exciting. So a catalyst is just a substance that would speed up a chemical reaction and make it happen faster. Now, in a chemical reaction, the catalyst doesn't change. So for our chemical reaction today, we're going to add yeast. Yeast is going to be yeast in the beginning. Yeast is still going to be yeast at the end. It's not part of the chemical equation, okay? But we are going to add yeast as our catalyst. It's going to make everything happen faster. It's going to make the oxygen come out faster so that we'll know that a chemical reaction happened. When we talk about chemical reactions, we need to remember the law of conservation of matter. The law of conservation of matter states that matter cannot be created nor destroyed. So if I'm watching a chemical reaction happen, I'm not going to come over here and pick something up and throw it in, and I can't just stick something in my pocket and pretend that it's not there anymore. We need to remember that the number of atoms does not change. Those molecules and those atoms are just moving around and changing and bonding with different atoms. So if we started with hydrogen peroxide, we're going to end up with water and oxygen gas. We have to have the same number of atoms. Okay, so look here. If we start with 2 molecules of hydrogen peroxide, we have 2 atoms of hydrogen here and 2 atoms of hydrogen here, okay, for a total of 4 hydrogen atoms. We have 2 oxygen atoms here and 2 oxygen atoms here for a total of 4 oxygen atoms. Okay, those little 2's tell us how many atoms we have of that element. So a chemical reaction is going to happen. We're going to add yeast. We're going to add soap for fun. We're going to add color for fun, food coloring just for fun. Those are not part of the chemical equation. The catalyst is the yeast. So then this means a chemical reaction happened. We're going to end up with 2 molecules of water and 2 molecules of oxygen gas, or a molecule of oxygen gas. So here, watch, you've got 2 hydrogen atoms and 2 hydrogen atoms for a total of 4 hydrogen atoms. Then we've got, this means, because there's no little number there, it means we only have 1 atom of oxygen there. We have 1 atom of oxygen there. And over here we have 2 atoms of oxygen. So this is a balanced equation. We have 4 atoms of hydrogen in the beginning, 4 atoms of oxygen. We have 4 atoms of hydrogen in the beginning and 4 atoms, or in the end. And we have 4 atoms of oxygen in the end. We did not create matter. We did not throw away matter and hide it. We have the same number of atoms in the beginning as we do in the end. Okay, that has to happen. It doesn't happen differently. Okay, so something we need to remember is that there's 3 clues that a chemical reaction is happening, okay, that we need to know. One is a color change, and that does not include food coloring. We are adding color to our experiment today, okay? A temperature change. Is it getting warmer or is it getting colder all on its own just because a chemical reaction is happening? And is there a new gas happening? Are there bubbles being produced? That's our clue that there's a new gas, okay? So we're looking for these 3 clues today. I'm really sad that you guys can't feel the temperature change. These are things you need today if you want to do it, okay? Hydrogen peroxide from a beauty store works best, but you guys can't get that right now unless your mom's a hairdresser. So you can use regular hydrogen peroxide because I tried it and I'll show you that later. Food coloring, I'm using green. If you guys have food coloring, use whatever you've got. You need some dish soap. The dish soap is there just to catch the gas bubbles, because if the oxygen gas is escaping and we don't have the soap there to catch it, we don't see that the oxygen gas is coming out. We can't see oxygen gas. You need some really warm water and you need some yeast. The yeast is the catalyst that's just going to speed up the reaction. You're going to need a bottle, like a water bottle, a plastic water bottle, a tray or something to catch the mess. You need a teaspoon. You guys won't have graduated cylinders, so a couple cups to measure stuff. So here's where, if you want to get your stuff, go ahead and get your stuff, or watch through the whole video and then see if you could do it later. So if you need to, pause the video and then we'll come back. Okay, my friends, so I want you to see what's going to happen today. As we go through and we do the chemical reaction, here would be 2 molecules of hydrogen peroxide. It's H2O2. There's 2 atoms of hydrogen and 2 atoms of oxygen in each molecule of hydrogen peroxide. So when the chemical reaction happens, we start with 2 molecules of hydrogen peroxide. That's our reactants. Those are the things that are going to change. What's going to happen is we don't gain atoms, we don't lose atoms. They move around and they bond differently and they make something different, but we end up with the same number of atoms. So right now we've got 4 hydrogen and 4 oxygen to start. Watch what happens. We add everything in, the yeast is in there, the chemical reaction is happening. It's going to turn out going H2O. Oops, I moved that up too far. H2O, which is water, and we end up with oxygen gas that escapes. We don't gain or lose anything. That's what the law of conservation of matter says. We don't gain or lose matter. It just moves around and changes to form different substances. I have already pre-done some of the stuff to save time. So the first thing I did is I took 30 milliliters of warm water and I mixed the yeast in and I stirred it up real good. So this is my yeast and water mixture. Okay, the yeast is the catalyst. It is not going to be part of the chemical reaction today. Okay, so then it says to place the bottle in the middle of a pie pan or in the middle of a bowl, because it might make a mess and we don't want to mess. I put paper on the bottom just because otherwise it's a little bit shiny and I didn't know if that would bother you. So then it says measure 80 milliliters of hydrogen peroxide and pour it into the medium beaker. Okay, so now we have to pour that into the bottle. Now, hydrogen peroxide, clear liquid, it's just room temperature. Okay, so I'm going to pour it into my bottle now. Okay, there's 80 milliliters of hydrogen peroxide. Now keep in mind, this is hydrogen peroxide that I got from a beauty supply store. It's not the hydrogen peroxide that you get at like CVS. So then it says add 10 drops of food coloring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 drops of food coloring. So now our hydrogen peroxide is green. We added that color. That is not a color change. We took green and added it in. So then it says add 2 teaspoons of dish soap. So I already measured out the dish soap for the sake of saving time. And I'm gonna pour that in. All right. Then it says pour the yeast mixture in all at once, okay? So we know that over time, hydrogen peroxide will separate out into oxygen and water. The little gas bubbles will come out slowly. The yeast mixture is our catalyst. That's what's going to speed up the reaction. It's gonna make it happen fast, okay? So you ready? You're watching? Gosh, I wish we could do this together. Oh, it's killing me. Okay, you ready? Watch. All right, so look, can I get you a better angle? Look, right? Look at it. It's so cool, right? So now the bubbles are there only to catch the oxygen gas. The bubbles are very, very warm, but it's just oxygen gas in those bubbles. So it's okay that you touch them, okay? It's okay for you to touch them. It made a huge reaction. All the oxygen gas came out really fast. Okay, so the clues that we have that a chemical reaction occurred, the green is there because we added green. So there is no color change. But what our clues are is it created a gas because we started with a liquid. So it did create a new gas, okay, the oxygen gas that came out. So that's one, is that we got a new gas. The other thing is that it's very warm. So we have a temperature change and we have a new gas being created. We do not have a color change with this one. The green is because we added it in. Okay, so I have not done elephant toothpaste with just using regular hydrogen peroxide from the grocery store. So we're gonna try it because maybe you guys can do this at home. We're gonna try it, okay? So I've already measured everything out again. Okay, so the first thing we do is we need to put in our peroxide. So this is just regular grocery store peroxide. And then we're going to put 10 drops of food coloring. 4, 5, 6. So we've got green peroxide now. The next thing, we're gonna pour in our soap. The soap is just there to catch the bubbles. Okay, so right now, we've got soap, peroxide, and food coloring. And now we're gonna add our yeast, which is not part of the chemical reaction either. The yeast is just a catalyst. It's gonna make the oxygen come out faster, okay? So let's see what happens. I don't know. I've never done this. Okay. Oh, maybe it does work. It does work. Oh my gosh. Sorry. Okay, so this is what I used. It didn't happen as big as the other one, but it did happen. Okay, it's not really toothpaste, you guys. They call it elephant toothpaste because it looks like toothpaste when it comes out. Do not put it in your mouth. So yes, you can still touch the bubbles. It's just oxygen in the bubbles. It went from being hydrogen peroxide to oxygen gas and water. What is left in the bottle, you've got water, you have food coloring still, and you would have yeast, okay? So your reactant in this one is hydrogen peroxide. Your products, the things you end with, are water and oxygen gas. The yeast is the catalyst. It speeds up the reaction. The soap and the food coloring are just for fun. So knowing now that this happened like this with this, you guys could do this. If you do it though, you have to have a bowl or something underneath because obviously it makes a mess. And I would suggest doing it outside, okay?